Appliances that supply electrical power during a power outage and prevent discontinuity of daily activities or disruption of business operations. Generators are available in different electrical and physical configuration for use in different applications. In the following section, we will look at how a generator functions, the main components of a generator, and how a generator operates as a secondary source of electrical power in residential and industrial application. How does a generator work? An electrical generator is a device that converts mechanical energy obtained from an external source into electrical energy as the output. It is important to understand that a generator does not actually create electrical energy. Instead, it uses the mechanical energy supplied to the force of movement. Electric charges present in the bar of its winding through an external electric circuit. This flow of electric charges constitutes the output electric current supplied by the generator. This mechanism can be understood by considering the generator to be analogous to water pump, which causes the flow of water but does not actually create the water flowing through it. The modern day generator work on principle of electromagnetic introductions discovered by Mitchell Faraday in 1831 to 1832. Faraday discovered that the above flow of electric charges could be induced by moving an electrical conductor such as a wire that contains It is important to understand that a generator does not actually create electrical energy. Instead, it uses the mechanical energy supplied to it to force the movement of electric charges present in the wire of its winding through an external electric circuit. This flow of electric charges constitute the output electrical current supplied by the generator. The modern day generator work on the principle of electromagnetic induction discovered by Mitchell Faraday. Main components of a generator are as follows. The main components of an electric generator can be broadly classified as follows: engine, alternator, fuel system, voltage regulator, cooling and exhaust system, lubrication system, battery charger, control panel, main assembly, and frame. A description of the main component of a generation is given below. The engine is a source of input mechanical energy to the generator. The size of the engine is directly proportional to the maximum power output the generator can supply. There are several factors that you need to keep in mind while assessing the engine of our generator. The manufacturers of the engine should be consulted to obtain full engine operation specification and maintenance schedule. Types of fuel use: generator engines operates on a variety of fuels such as diesel, gasoline, propane in liquefied or gaseous form, or natural gas. Smaller engines usually operate on gasoline, while larger engines run on diesel, liquid propane, propane gas, or natural gas. Certain engines can also operate on a dual feed of both diesel and gas in B-fuel operation modes. Overhead value: OHV engines versus non-OHV engines. OHV engines differ from other engines in that the intake and exhaust valves of the engine are located in the head of engine cylinder as opposed to being mounted on the engine block. OHV engines have several advantages over the other engines such as compact design, simpler operation mechanism, durability, user-friendly in operations, low noise during operations, low emission levels. However, OHV engines are also more impressive than other engines. Cast iron sleeves in engine cylinder. The CIS is a lining in the cylinder of engine. It reduces wear and tear, ensure durability of engine. Most OHV engines are equipped with CIS, but it is essential to check for this feature in the engine of a generator. The CIS is not an expensive feature, but it plays an important role in the engine durability, especially if you need to use your generator often or for long durations. Alternator, also known as Jan heat, is the part of generator that produces electrical output from mechanical input supplied by the engine. It contains an assembly of stationary and moving parts encased in a housing. The components work together to cause a relative movement between the magnetic and electric fields, which in turn generates electricity. Stated. This is the stationary component. It contains a set of electrical conductors wherein the coils over Iron core rotate armature. This is the moving components that produces a rotating magnetic field in any one of the following three ways. By induction, these are known as brushless alternators and are usually used in large generators by permanent magnets. This is the common in small alternator units by using an exciter. The exciter is a small source of direct current DC that energizes the rotor through an assembly of conducting slip rings and brush. Okay. The rotor generates a moving magnetic field around the stator, which includes a voltage difference between the winding of the stator. This produces the alternating current of the generator. The following are the figures that you need to keep in mind by assessing the alternative of a generator. Metal versus plastic housing. An all metal design ensures durability of alternative plastic housing get deformed with time and cause the moving parts of alternator to be exposed. This increases wear and tear and more importantly hazards to the users. Ball bearing versus needle bearing. Ball bearing are preferred and last longer. Brushes design and alternator that does not brushes requires less maintenance and also less clearance. The fuel tank has sufficiently capacity to keep the generator operational for 6 to 8 hours on average. In the case of small generator units, the fuel tank is a part of the generator's kit base or is mounted on the top of the generator frame. For commercial application, it may be necessary to erect and install an external fuel tank. All such installations are subject to the approval of city planning divisions. Click the following link for further detailing. Common feature of the fuel system include the following: pipe connection from the fuel tank to engine. The supply line directs fuel from the tank to the engine, and the return line directs fuel from the engine to the tank. Ventilation pipe for fuel tank. The fuel tank has a ventilation pipe to prevent the buildup of pressure for vacuum during refilling and drainage of the tank. When you refill the fuel tank, ensure metal to metal contact with the filler nozzle and the other to avoid to spark. Pipe connection from fuel tank to engine. The supply line directs fuel from the tank to the engine and return line direct fuel from the engine to the tank. Ventilation pipe for fuel tank. The fuel tank has a ventilation pipe to prevent the buildup the pressure vacuum during refilling and drainage of the tank. When you refill the fuel tank, ensure metal to metal contact between the filler nozzle and the fuel tank to avoid sparks. Overflow connection from fuel tank to the pipe drain pipe. This is required so that any overflow during refilling of the tank does not cause spillage of the liquid on the generator set fuel pump. This transfers fuel from the main storage tank to the day tank. The fuel pump is typically electrically operated. Fuel water separator, fuel filter. This separates water and foreign matters from the liquid fuel and other components of generators from corrosion and contamination. Fuel injected. This automizes the liquid fuel and separate the required amount fuel of into the combustion chamber of the engine. Voltage regulation. As the name implies, the component regulates the output voltage of generator. The mechanism is described below against each component that play a part in the cyclical process of voltage regulation. Voltage regulator conversion of AC voltage to DC current. This voltage regulator takes up a small portion of the generator output of AC voltage and converts into the DC current. The voltage regulated then feeds this DC current to a set of secondary winding in the stator known as exciter winding. Exciter windings conversion of DC current to AC current. The exciters winding more function similar to the primary stator winding and generate a small AC current. The exciter winding are connected to unit known as rotating rectifiers. Rotating rectifiers conversion of AC current To DC current, these rectify the AC current generated by the exciter winding convert into the following things as well.